Hi guys, I'm NK. Welcome to No Family. In today's lecture, we are solving out the question related to the differential equation. Question says that solve the differential equation dq minus 3d square plus 9d minus 27 into y is equal to cos 3x. Solution. At first write down given here here A is given by here A stands for the auxiliary equation. For finding out the auxiliary equation, put the capital D is equal to m. Then we get m cube minus 3m square plus 9m minus 27 is equal to 0. It's a cubic equation. Either you find out by the factor of the 27, either you find out by the roots by hit and trial. Either you take out the common. When we take out the common, we get from first two term m square take out as a common. Then we get m minus 3 plus 9 take out the common in from last two term. Then we get m minus 3 is equal to 0. From here we get m minus 3 is a first factor, and the another factor is m square plus 9. M square plus 9 is equal to 0. When we put equal to 0 one by one, when m minus 3 is equal to 0, m is equal to 3. And when m square plus 9 is equal to 0, m is equal to plus minus 3 iota. Now CF is given by hence CF is equal to, we know that when the roots are real, then CF is C1 e the power ax, C2 e the power bx. Here one root are real, so C1 e the power 3x plus, we know that when the roots are complex conjugate, then solution is e the power alpha x bracket C1 cos beta x plus C2 sin beta x. So here e the power alpha x, the value of alpha is 0, so e the power 0x. C1 cos beta x, so C1 cos 3x plus C2 sin 3x plus C2 sin 3x. Now CF is equal to C1 e the power 3x plus C2 cos 3x plus C3 sin 3x. C1, C2 and C3 are the arbitrary constant, so you can take out as per your choice. You can take out in mid, you can take out at the last. Everywhere you can take out the C1 and the C2 values, but not similar. If C1 is another, C2 is another, and C3 with the another terms. Now Pi is given by, Pi is equal to for finding out the Pi, write down the RHS part of the given equation in numerator, that is cos 3x upon the LHS part here the function of d in the denominator, that is d cube minus 3d square plus 9d minus 27. D cube minus 3d square plus 9d minus 27. When we apply the identity cos ax upon fd square, then we get the 0 of the total term. So don't apply that term. See, so pi is equal to pi is equal to cos 3x is as it is, cos 3x is as it is, upon the function of d square in denominator, and the factor is d square plus 9 d minus 3, d square plus 9 plus 9 and d minus 3, d minus 3. Now we studied some identity in earlier classes. The identity says that if cos ax in numerator, cos ax in numerator upon function of d square in denominator, fd square in denominator, then we can write down cos ax as it is, cos ax is as it is, upon d square is replaced by function of minus a square. D square is replaced by function of minus a square. But when we apply the same terms here, we get minus a square plus 9. A here, a is 3, so minus 9 plus 9 is 0. So that is not possible in denominator. So now we apply another method. Pi is equal to Pi is equal to 1 upon d square plus 9, take out outside because it's becomes 0. D square plus 9, and another terms in inside, that is cos 3x upon d minus 3, d minus 3. Now for formation of d square in denominator, we carry out the multiplication of the conjugate of denominator, that is d plus 3, d plus 3 upon d plus 3. So now we apply the method and solve out. Then we get pi is equal to pi is equal to 1 upon d square plus 9 as it is. Here the denominator become d square minus 9. A plus b, a minus b is always a square minus b square, and then denominator become d plus 3 cos 3x, cos 3x. Now we again solve out. So pi is equal to pi is equal to 1 upon d square plus 9 as it is, so d square plus 9 as it is. Now apply the identity cos ax upon function of d square, that is we study, write down the at upper part. So apply here. So d square stands for minus 3d square, that is minus 9, and the numerator become d stands for d by dx, differentiation of the function with respect to x, into cos 3x, cos 3x plus 3 cos 3x plus 3 cos 3x. Now we solve out. Then we get pi is equal to pi is equal to 1 upon d square plus 9 as it is, 1 upon d square plus 9 as it is. Take out upon minus 1 upon 18, so minus 1 upon 18. The differentiation of cos x is minus sin x, so it's become minus 3 sin x, minus 3 sin, here 3x, so it's 3x plus 3 cos 3x plus 3 cos 3x. Now apply here, cancel out the terms, and we get pi is equal to take out the 1 upon 3 common, then we get 1 upon 6 outside, d square plus 9 inside, then it's become sin 3x upon d square plus 9 minus common, so it's become cos 3x upon d square plus 9. Now identity says that, now again apply the identity says that if sin ax upon d square plus a square is given, then the solution is minus x upon 2a cos ax, it's our solution. And the second one is if cos ax upon d square plus a square is given, then x upon 2a sin ax is solution. It's the solution. We apply both and solve out, then we get pi is equal to, pi is equal to 1 upon 6, take out as a common, then 1 upon 6 sin ax upon d square plus a square, so it's become minus x upon 2 into the value of a is here 3, so 2 into 3 cos ax, so cos 3x plus x upon 2 into 3 sin 3x, so sin 3x, it's our pi. Now find out the complete pi, then we get pi is equal to take out minus as a common, x upon 2a cos 3x upon d square plus 9, then here minus is given, so it's take out the minus, it's minus is already given here, so it's a minus. Now pi is equal to minus, take out as a common, so minus 1 upon 36 x cos 3x plus x cos 3x plus x sin 3x, it's our pi. Now general solution is given by, hence GS stands for general solution is y is equal to CF plus PI. CF stands for complementary function, PI stands for particular integral. So y is equal to, at first write down the CF, that is C1 e the power 3x, C1 e the power 3x, e the power 3x plus C2 cos beta x, that is 3x, plus C3 sin beta x, that is sin 3x, minus 1 upon 36 as it is. Take out the x as a common, then it's become x upon 36. Then it's become x upon 36. X upon 36. Cos 3x as it is, so cos 3x plus sin 3x as it is, so sin 3x. It's our final solution. I think you understand how we can solve out the given question by the using of algebraic identities and the function of the algebra. Y is equal to C1 e the power 3x plus C2 e the power cos 3x plus C3 sin 3x minus 1 up x upon 36 cos 3x plus sin 3x. It's our final solution. I think you understand how we can solve out the given question by the using of algebraic identities and the trigonometric formulas and auxiliary equation. Now our lecture is finished. Jai Hind, Jai Bharat.